In this video, we are going to do option valuation with the binomial approach. So option values, binomial trees. To calculate the option value using this method, we first start with a set of data, a set of figures that we're going to use to work our way down to get to this number. This first example is a European option, meaning that you can only exercise it at the end of the period. Let's go over the numbers. So S0, that's going to be our current price of the stock price at period 0, $50. We are going to say that if it goes up, it will go up by 6%. If the price goes down, it'll go down about 5%. Those are the expectations. The risk-free rate in this example is 5%. And the strike price of the option is $51. The period that we're going to be working with is 3 months, each period, and we're going to do a total of 2 periods. So in reality, it's a total of 6 months, but 3 months at a time. So the first thing we want to do is we want to calculate some factors of up and down in price, and then some probability of it going up and probability of going down. So to get started, to get this factor, what are we doing is we just doing the growth factor. So if it's expected to go up by 6%, then all you got to do is 1 plus that 6%. And there's our up factor. For a down factor, since there's a loss going down, we're doing just 1 minus the down percentage, 5%. Okay, now once we have those numbers, we want to calculate the probability of it going up and the probability of it going down. Now, for that, we're going to use this formula here. This gives you the up probability. And then once we have the probability of it going up, we can then calculate the probability of it going down. So that's why you see here, up move probability is P. Down move probability is 1 minus P. So once we have that, we can get this one. So looking at the formula, we're following this formula here. So let's look at the top piece first. Let's look at the top left piece first. That is continuous compounding. We use Euler's number with an exponent of the rate that we're going to use, in this case, the risk-free rate, and the time. And that one's going to be this first piece here up to there. That highlighted piece is Euler's number, the way you would write it in Excel. So you put a function of exp. We do have the parentheses there, so we can separate accordingly. We use the exp1 to represent Euler's number, but then we're going to elevate it to the RT piece. C5 is the R. That's the 5% risk-free rate per year. But since it's only a set amount of time, we're not doing the entire year, or we're doing 3 months at a time. We're looking for the number 3 months from now. So that's why you have this risk-free rate, which is C5, multiplied by C7, the 3 months, divided by 12. So if it's every 3 months, you divide it by 12, you get 1/4 of a year. That represents the 3 months. So it's only 1/4 of the risk-free rate. So this adjustment is to make it, instead of a year, instead of 12 months, is how many months is the period we're looking at. Now that we have that piece there, we want to do the minus the down movement. So that's minus C11, which is the D that you have there. That's a down movement, 0.95. All right, so once you have these numbers from here to here, that represents the top part of the formula. And that's why we have parentheses around it to isolate it. So it follows order of operation. So the division sign, and at the bottom, we do need it in parentheses. It's just U minus D. So we just take the 1.06 minus the 0.95. And that completes the formula for the up probability, 0.5689. Now the probability of it going down, you just do 1 minus the probability of going up. And that gives you the probability of going down, 0.4311. Okay, so once we get past this calculation, we want to know is where will the stock price end if it follows the pattern of going up in price twice, going up in price once and then down, or down in price twice, and so on. So this is what we're going to do here. Remember, it's every 3 months for 2 periods. That's why I have here up and up. So we say first 3 months it went up, and on the second 3 months it went up again. So it's 2 times we could have gone up. So what we have here is the current price of the stock times the factor that we have here if it goes up by 6%. So that'd be the first 3 months. But since we're going to calculate what happens if it goes up in the next 3 months as well, then we multiply it again by the 1.06, the factor. So if the stock price goes up twice by the expected up percentage, you will move from $50 to $56.18. If we were to look at it in a tree, we're talking about this line here. It went from 50, first 3 months, 53, second 3 months, 56.18. So it does up and up again. And that's what we have up and up, 56.18, 56.18. But what happens if it follows a different path, up and down? So we said it goes up, but then it goes down by the factors that we have here. So if that happens, we have this stock price of 50. First, it goes up. So we multiply by the up factor, but then it's going to go down. So we multiply by the down factor. And that's why in this case, $50.35. And that's why you see that number there. Here, if it goes down first and then up. Now, yes, you're ending up in the same place, but it matters the order in which it happened for a later calculation. Up, down, and down, up. Yes, you get the same number because you're just multiplying the same numbers in different order. However, later when we do the evaluation, it's important to understand that there are 2 paths to get to the same number. This is one path, up and then down, and there's a different path, down and then up. This becomes important for the present value calculation. Now, what happens if it goes down twice? Down the first 3 months and down again the next 3 months. So we take the stock price, we multiply by the factor of going down for the first 3 months, and then down again for the second 3 months. And that's why we have the same number twice. And you see here, 45, here's rounded, 45.13. Here is not rounded, 45, or less rounded, 45.125. So this is the stock price after 6 months, what is expected, the 4 different potential outcomes 6 months from now. Now, the question is, well, what is the payoff from the call option? What is the value of that call option at the end of those 6 months? So now we have these numbers here, which is this number, and this number, the stock price at the end of 6 months. Once we have the stock price, we can assign the value directly to the option because the time is over. There's no more to go, so we can know the final value of the option. So if it's up and up, the pattern this way, we do know it's a 56.18. So let's go back and look at our strike price. If you have a call option with a strike price of $51, that means that you can buy it for $51. That was the deal that you entered. And if the stock is currently trading at 56.18, that 56.18, that means that you can make money by exercising the option. That's one way to do it. You buy for $51 and you immediately sell it for 56.18. So that profit that you make is what we calculate in here. Now I have an if statement there, and I have an if statement in order to adjust the calculation if I change the inputs. However, what's really going on, all you're doing is you are checking if this number, and there's on the call option, if this 56.18, this is what the if function is doing. The if function here, this if function here, is checking if this number is higher than this number. So if this number is higher than this number, then yes, exercise. And then what you do is you take this minus this equals $5.18. And that's how we get the 518, which is the number here. That means that the value of that option at the end of the 6 months is worth the difference between them, because you can make money by buying it at 51 and selling for 56.18. Now these are zero, and the easy way to explain it, we'll get to the calculation in a moment, is that, well, at 50.35, which happens in these two, versus a strike price of 51, that means that it's not prudent, it's not convenient for you to buy it at $51 and then sell it at a loss of 50.35. So you're better off just letting the option go. So there's no value. You don't exercise. So you better have no value of the option that have a loss. So because these numbers are less than the strike price, then there is no money to be made. Therefore, the value of the option is zero. Same story here. The down and down situation is 45.13 or 45.125. That number is less than the strike price. So you don't want to exercise it because you don't want to buy it at 51 and sell it for less than 51. So therefore, that's zero. So when the stock price in a call option situation is higher than the strike price, then sure, take your profits. And that's the value of the option. But now the question is, what is the value of that option today if these are the potential outcomes? These are the 4 potential stock prices in this scenario in the future. And these will be the payoffs of those potential outcomes in the future, the stock price. But I need to know now that I know what it could be in the future, how much is all that worth today together? And that's the number we're going to calculate here. So for the stock price, we went from left to right, from left to right, from left to right, and from left to right, in all possible paths. So these are expected future, possible futures of the stock price based on this probability and these up and downs. But how much is the value of that option today? So what you do is, once we have these numbers of 518, the 0 and the 0, we can do the present value of those potential values of the stock, of the option in the future. So what we're going to do is we're going to do a present value of these. So now we're going to go from right to left, but instead of using the stock price, we're going to use the option value. Now, since we don't know which one is going to be the reality, all we can do is assume the probability of these happening. So that's why this formula is now going to include these 2 factors as well. So let's start with how this formula works. It's a little lengthy, but it's pretty much repeating a calculation for each potential outcome. Let's talk about this first part here. This first part that you see there That is pretty much the same as the continuous compounding we did up here, except that this is continuous discounting because you're going from the future to the past. When we're doing the stock price from the present to the future, we use continuous compounding with Euler's number. But now that we're doing present value, we're going from the future value of the option into present value. So we're discounting. So this is pretty much the same as that, except that we have a negative right there in front of the C5. That's a negative. That's how we make it discounting. So Euler's number function in Excel is exp with a 1 in parentheses. That's Euler. That's the E portion, that E that you see there. And now C5, we are using the risk-free rate again. But like I said, put a negative. So now we are in the discounting approach. But we're going to go to multiply by C7, which is the 3 months. But now, because we're doing the entire way, all the way to 6 months, we are going to do C7 times the 2 periods. So now it's really a 6 divided by 12, because we're going to do the present value all the way from the end of the 6 months to today. So instead of just doing 3 months at a time, we're going to do a present value of all 6 months at a time. And that's why you see that here. C7 multiplied by C8 to get the entire 6 months, divided by 12 to represent half a year. All right, so once we got that continuous discounting piece, now we're going to start talking about the probability of each one of these. So let's start here. C22, that's our $5.18. So we're talking about this one here. So the way we got there was by 2 upwards movements. So that was up, and that's how we got there. So when we're going to do present value, the path up to that number is up and up, meaning we're going to use the up probability twice because it was 2 steps. There's a probability each one of them. So I grabbed the C22, which is the 518, and I'm going to multiply it by C12, which is the up probability. And then I'm going to multiply it again because it's 2 steps. Every 3 months, that's the probability. And that's how we move this 518 to present value down here. But we're not done yet because that's just one possibility. We need to work with all the possibilities back. All right, all the potential paths. So I'm going to add it, that's the plus sign, to C23, which is the up and down, was up and down. So I'm going to grab the value of the option at the end of C23, and I'm going to multiply by C12 because there was 1 up, right? But there's also 1 down. So I'm going to do C13 now, which is the down probability. Remember, we got there by up and down. So once I have the value of the option in that position, I'm going to multiply the probability of that happening, up and down. That's that path. So now we're going to do the other path that ends in the same place, but it went down and up. So I'm going to grab C24 in this case, which is the down and up path, not the up and down, the down and up, multiplied by the down movement probability, which is the 0.4311, C13, multiplied by the up movement. And that's because that's the way that we got there, down and up. Last but not least is this number, and that one was down and down. So I grab this C25, which represents the number here, the value of the option there, multiplied by the down movement probability, 4311, in the cell C13. But it was 2 times it did it, so I got to do it again. So now when I add all these together, that's why the plus signs, what we have is, and multiplied by the continuous discounting, we have a present value of the probable option values outcome. Now, some of y'all probably noticed, but those are zeros. Why bother? I'm showing you the entire formula because these may not always be zeros. So might as well you have the formula as a whole, and it will capture anything that ever goes in there, whether it's a 0 or not. And that is the $1.64. It's the same as that 1.63 there. It also expanded. 1.635. And that is the value of that option today based on these probabilities and the percentages of up and down in price. It's because you don't know, but there is a possibility of it having value at the end. So that's the present value. Okay, so this is the exercise working it if you're in the call option. Now let's see what happens if you are in a short position. You're in a put. So this side here is the same numbers you see here, but in a put. So you're not in a call. So here you make money if the stock price goes down. So you have these inputs, the exact same ones as this one. This calculation here, same calculations you have here. Those don't change. Same formulas, all of them, because the probability of it going up is the same as the probability going down and is the same stock. So that doesn't change just because you're in a put. Now here, this doesn't change either, because that is the price movement that could happen based on these calculations. So the only real thing that changes is how you look at this binomial tree here and the option value of the put. These are all behaviors of the stock and probabilities of the stock, so it doesn't change. But because you're in a put position, in a short position, you bought a put instead of a call, this is the part that changes. And the tree looks a little different because of it. So this is what happens. Notice that the price is the same, 50, 53, 56, 18. If you go up and up, up, down, up, down, down. So all that is the same up to that point. However, remember, in the call, you make money if the stock goes up. In the put, you make money if the stock goes down. So if the stock price ends up at 56.18 and your strike price of 51, when you're in a put position, it flips the script. This is saying that it is the same as saying that you would buy it for 56.18 and sell it for 51. That is not convenient. That doesn't make you money. You lose money. And that's why here the value of that option will be 0, because you wouldn't want to exercise it. There's no value in buying something for 56 and selling it for 51. Now, what happens when it's 50.35? That's a different story. That means that you are selling it for 51 and buying it for 50.35. So that's why here you see that 65 cents. So 0 here for that one, 65 cents for this one, because you can make that 65 cents per share, because you can sell it for 51 and buy it for 50.35. The down up situation, we already explained it. That's why you still have the same number, but it's a different path and must be considered. And then the down down is your most lucrative one, because if the stock price ends up in 45.13, that means you are selling it for 51 and buying it for 45.13. So when you take the difference between 45 and the 51, you get the 588. Now, same story. We know the potential values of the option in the future. So we want to get the present value of that option with these potential outcomes in the future. So the calculation is the same, but the number is different because the way you make money turned around. And that's why earlier I said have the entire formula in there. That way, when these zeros may not always be zeros like here, you still can get the right amount. So now let's put this in the front so it looks the same as the other one. Talk about it in the same fashion. So there you go. So this first piece is done exactly the same like we did earlier. That's the continuous discounting. Euler's number, raised to the risk-free rate with a negative to represent discounting, times the 3 months times 2 periods for the entire 6 months, because we're doing present value all the way. And that's what's divided by 12 to represent the 6 months, half a year. And then we're going to multiply by the numbers like we did before. K22, which is our up, in this case 0, multiplied by the up probability twice. K12, up probability, K23 follows an up and down. So we do K23, which is our 0.65. It follows up and down. So there we have the up probability times the down probability, plus K24, which is 0.65 again. Remember, even though they end up in the same place, it was 2 different paths to get there. So, but that one was down and up. So we do the down probability times the up probability, plus K25 or $5.88. That one was a down situation. So the down probability times the down probability. Those get added up together inside the parentheses, multiplied by the continuous discounting formula. And your value of that European option today, the present value is 138, rounded. You can see the 1376, just like that. One last piece for this video. It's what we call the put-call parity. Since these two items belong to the exact same stock during the exact same period, there's a relationship between these two values. For example, let's say we did all this call option calculation, right? And we got to have $1.64. I can go ahead. So it looks like the 1.635. That's the call value that we calculated here. Now, if we calculate the present value of the strike price, in this case, the $51, multiplied by the continuous discounting, let's look at the formula. We have the $51 here, C6, times Euler's number, raised to negative risk-free rate, the 6 months, 3 times 2 for 6 months, divided by 12 to make it half the year. When you do the continuous discounting on the strike price for present value, the present value of the strike price is $49.74. If you add those two together, you get a $51.38. The importance of the number is this, that if I have some of these values, I can tell what the put value is without having to do this calculation. This is how it would work. Because the parity means, the parity is this formula here. Call value plus the present value of the strike price equals the put value times the stock price now. So the put value times S0, which is the stock price now, $50, would add up to $51.38. Let's go ahead and expand those decimals so it all makes sense. All right. So what we're saying is that if you already have these values here, then you can grab that 51,376, subtract the stock price, and you can get the put value without having to go through this. So this number minus that number will give you the put value without having to calculate. And it works the same the other way around. Let's say you have the put value, and you know that if you add the stock price, you'll get 51,37.6. So you take the 51,37.6, subtract the present value of the strike price, then you will get the call value. And that's the put call parity. When you're dealing with the same asset, if you have one, you can easily find the other. Or you can go ahead and do each one of them separately. That will be it for this video. See you on the next one.